In this lesson, given an angle or an arc, right, so in degrees or in radians of any angle, I will be able to determine its corresponding points on the unit circle. Ooh, the unit circle, this is exciting. And resultantly, right, so that is like the first piece of this. Given any degree or radian measure, you're going to find a corresponding point, right? So that's like an XY coordinate point. So if you think about it, it's if I know this angle is 45 degrees, I want to know what is this point, right? What is the X and the Y that takes me there? Oh, look, you have a triangle. That's why the special right triangles are so important. And resultantly, determine the exact value of the 6 trigonometric or circular functions, right? So that's sine, cosine, tangent, secant, cosecant, and cotangent, those 6. So just knowing that point, we're going to be able to determine any of this information, all of this information. So here we have the unit circle. So why is it called the unit circle? Oh, because the radius is 1. Right? And then this right here, so if you remember, you're always starting right here on the positive x-axis, and a positive angle or radian is going counterclockwise, right? Here, let's remember that. Positive is counterclockwise, negative is clockwise, right? And you had 30 degrees is pi over 6, 45 is pi over 4, 60 is pi over 3, 90 is pi over 2, right? You're looking at fractions of a semicircle. And then just from 0 to 2 pi, we're just going to look at this as it's that one rotation. The radius, so this length right here is 1. What's this length? Oh, also 1. What would this length be? Oh, also 1. Let's see, what if I did this right here? What is this angle called? Oh, that's a reference angle. So maybe you're starting to see why these are so important. Right, if we know the reference angle for something like 4 pi over 3, it's going to help us to figure out what is this actual coordinate point. So by the end of this lesson, I'm going to put this picture back up, and we're going to be able to identify the coordinate points for every single one of these points, every single one of these special angles. All right, so if you remember, I wrote over that, from the last unit, we talked about the equation of a circle. The equation of this particular circle is x squared plus y squared equals 1 squared, right? So if I wanted this point right here, if I took the x value and squared it, plus the y value and squared it, it's going to equal to the radius squared, which is 1. In that first quadrant, so if I wanted this point right here, it's great, it's a nice circle, my x and y are going to be positive. What's going to be true if I picked a point over here in quadrant 2? Oh, my x is going to be negative and my y is going to be positive. What about quadrant 3? They are both going to be negative. And in quadrant 4, x will be positive and y will be negative. This is going to be good for us to remember. We're still working like this is 0, 0. It's centered at 0, 0. Okay, so back to the unit circle. The radius is 1. We're going to look at this 45-degree angle. We wanted to identify what this coordinate point is, right? To get to that point, you're going over x and up y. So the cosine, well, what is the ratio for cosine? Let's see, TOA. Oh, cosine, adjacent over hypotenuse. Well, if we're looking at this is going to be adjacent, this is going to be opposite, this is going to be the hypotenuse. So adjacent is x, hypotenuse is 1. Well, x over 1, anything divided by 1 is just itself. So your cosine of theta, of that 45-degree angle, is just going to be x. What about your sine? Opposite over hypotenuse, so it's just going to be y. So this coordinate point right here is really just cosine of theta, sine of theta, right? because we just said that cosine of theta is x and sine of theta is y. That's going to be true for any angle that I pick, right? If my hypotenuse is always 1, I'm always going to be going over x, up y, or left x, down, like any of that information. So it's always going to be a variation of cosine theta, sine theta. Right, so x squared plus y squared is r squared, which means that, oh, we said that x was the cosine of theta. So by substitution, I can say cosine of theta squared plus sine of theta squared equals 1 squared. This will also, and we're going to come back to this a little bit later, can be written as this: cosine squared theta plus sine squared theta equals 1. This is something you're going to work with a lot. This is a trig identity. It's going to come up a lot more next year, but a lot. So like for this, if I do the cosine of squared of 45 plus the sine squared of 45, it's going to give me 1. If I do the cosine squared of 30 plus the sine squared of 30, it's going to equal to 1. And you can check that in your calculator. If you do the cosine squared of 17 plus the sine squared of 17, it's going to equal 1. That'll always be true. You just have to make sure, if you want to check me on that, go for it in your calculator. Oh, I did it and I got 1. I did it with 17. Just make sure you're closing parentheses. So if you're not getting 1, then maybe you're putting it into your calculator incorrectly. All right, so the points x, y on a unit circle are the same as cosine sine. That's what I was just trying to get at, right? Cosine is x, sine is y. Of the angle created by radiating out from the center of the unit circle to the circumference, right? By that theta, that angle that we were talking about, where you start at the initial side and you end at the, where's the terminal side of the angle, what we were doing in the last lesson. One way to remember this, if you're not remembering it, it's in alphabetical order for your x, y, as well as your cosine sine. So if that helps you to remember it, fantastic. The cosine is x, sine is y. Cosine of theta is x, sine of theta is y. The other piece of this, and I was just talking about this on the last slide, if I square the cosine and the sine values of any point on your unit circle and add them together, it will always generate 1, which is the radius squared, right? The unit circle, it's a single unit. So x squared plus y squared equals r squared, meaning cosine of theta squared plus sine of theta squared equals to 1 squared. Back on the unit circle. So here's the point we were just talking about, that xy coordinate point, that cosine theta, sine theta. So let's look a little bit closer at it and actually define it for 45 degrees. Let's figure out what is the sine and what is the cosine. What is that actual coordinate point? So let's think about this. Well, we know this is 1. And you actually did this with the warm-up, so maybe you have it written down. Well, this is a 45, 45, 90 right triangle. Right? Your reference angle right here is 45 degrees. This is 45 degrees. These two sides are equal. Well, we have that special right triangle. Let's see if I can draw it. Of 45, 45, 90. And it was the two shortest sides and the shortest side root 2. So that means that 1 equals the shortest side times root 2. If you divide by root 2, oh, you get 1 over root 2 is this. So this side is 1 over root 2, and this side is 1 over root 2. So I'm going to go over 1 over root 2 and up 1 over root 2. So there's my coordinate point, 1 over root 2, 1 over root 2. You may also have this written as root 2 over 2, root 2 over 2 if you're rationalizing. So that means, the cosine of 45 is 1 over root 2, right? Because this is what is your y coordinate? And this is saying what is your x coordinate? Right, so this is also going to be 1 over root 2. or root 2 over 2. So what if we look over here and kind of look at where that terminal side, when it reflects over the y-axis, so that's a now 135 degree angle, right? So you're going from here and you're going, woo. So we want to know what is the reference angle for 135 degrees, right? What is this? That's now theta. I'm sorry, that's not theta. That's my reference angle. So what's that? 135 degrees was theta. Oh, right. So now we're going to look at it as the sine of 135 and the cosine of 135. Well, the reference angle is just 45 degrees, right? I really just have the exact same triangle, just reflected. So how much am I going to be going left? Oh, I'm going to be going left, negative 1 over root 2. I'm still going up. It's just the reflection, 1 over root 2. So this coordinate point is negative 1 over root 2, 1 over root 2. So your sine, which is your y-coordinate, is 1 over root 2, and your cosine, which is your x-coordinate, is negative 1 over root 2. Right? So if you know the reference angle and you know which quadrant it's falling in, you can figure these out. You've got this. And we can do that in the other two quadrants as well, right? So then I come down here. Well, what is the measure of this angle? I might need to clear this off, sorry. Unaware of how I'm supposed to do that. Can I do that? No, erase the pen, sorry guys. So when I do this angle right here, so I'm going all the way around to here. How many degrees is that? 225, right? That's a 225 degree angle. Well, what is the reference angle, right? That's going to help us identify this point. How much past 180 did I go to figure out what is just this reference angle in here? Well, that's also going to be 45 degrees. Right? So that reference angle is 45 degrees. So now I'm going to be going left 1 over root 2 and down 1 over root 2. So this coordinate point is going to be what? Oh, negative 1 over root 2, negative 1 over root 2. So if you think about it, we got this, and then we just use that idea of, oh, it's positive, positive, negative, positive, negative, negative, and what's this one going to be? Positive, negative. Right? That's really what we're using, is we have quadrant 1, and then we're just thinking about, well, where does that end up in the next quadrant? So then if you asked this, and I said, well, what is the sine of 225 degrees? Well, the sine is that y value, so it's negative 1 over root 2. The tangent of 225 is negative 1 over root 2. Here's a good one. What if not the tangent. I was thinking ahead. The cosine. What if I asked you for the tangent of 225? Well, tangent is sine over cosine, or it's opposite over adjacent, right? Oh, look, they're the same. If you divide them, you're just going to end up with actually positive 1, right? Like, what's the tangent over here? If I said the tangent of 45 degrees, you're also going to end up with positive 1. What if I asked you for the tangent of, what was this, 135 degrees? Oh, well, 1 is positive, 1 is negative, you're going to end up with negative 1, right? So you have sine is y, cosine is x, tangent is just y over x. Right? That's good for us to recognize. Let's look at that last quadrant. So what is the angle going to be when it ends up in that last quadrant? Let's get a new color. It's going to be 315 degrees, right? So starting here, going all the way around. And unsurprisingly, its reference angle right here is 45 degrees, right? It's 45 degrees away from being a full circle. So it's going to have the same process, but I'm going to the right, 1 over root 2, and down 1 over root 2. right? 1 over root 2, negative 1 over root 2. So your sine, this is your cosine of, what was it, 315? And then what will your tangent of 315 be? Negative 1. Awesome. So hopefully it's coming together a little bit. So, I mean, we kind of already did these, but just to reiterate, and these are things that you're going to know really quick. Like eventually, not this week, we're going to be looking at some practice speed trig quizzes, which you're missing out on because we're not at school. So don't worry, you'll get them in pre-calculus. But they're so much fun. And so we're going to make sure that we try to incorporate them in some manner moving forward. So prepare yourself for that. You want to know them quickly, and the purpose behind that is so that this is not a hindrance on our ability to be able to apply, right? Like we're doing this to kind of lay the groundwork or the building blocks. So the sine of 45 degrees, we just said, was 1 over root 2. Cosine's 1 over root 2. Tangent is 1, right? So that means that the cosecant of 45 degrees is root 2. The secant is root 2, and the cotangent is 1. Right? So once you have your x and your y, your sine and your cosine, you've got everything else. And then you just have to think about, well, where's that 45 degrees in any of the other quadrants to kind of think about the sines. So same idea if we said 135. I learned how to clear the pen, so I'm going to do it again. So if we're dealing with 135, well, this is in quadrant 2, but its reference angle is 45 degrees, so it's going to work the same. So this is still going to be 1 over root 2, right? But this is going to be negative 1 over root 2 because you're in the second quadrant, which means that you have negative positive, right? And then the tangent's going to be negative 1. They're the same value and you're dividing them, but one is negative. This is root 2, this is negative root 2, and this right here would be also negative 1. What if we changed it to radians, right? And we're looking at these circular values. Pi over 4. Well, where's pi over 4? Oops, sorry. No. There we go, pi over 4. So pi over 4 means that you're looking at a quarter of the semicircle. So that's right here, right? So pi over 4 is going to, oh, that is really bad. I missed. It's equivalent to 45 degrees, right? So, it's still going to be 1 over root 2 and 1 over root 2. So you're still going to get, for pi over 4, the sine is 1 over root 2. The cosine is 1 over root 2. The tangent is 1. The cosecant is root 2. The secant is root 2. The cotangent is 1. Right? When we look at it as 3 pi over 4, that's just going to be, well, that's 3/4 of a semicircle, right? That's the same thing as that 135. Oh, that's not a great color. Right, so this right here, from here to here, is 3 pi over 4. Or I guess from here to here, I guess would have been a better way to do it, is 3 pi over 4. My reference angle is still the pi over 4 right here, right? It's just the reflection. So I'm going to end up with, my sine is still 1 over root 2. My cosecant is still root 2. But my cosine is going to be negative 1 over root 2. So my secant is going to be negative root 2. Tangent's going to be negative 1, and cotangent will be negative 1. So it's just in radians as opposed to degrees there. What about 5 pi over 4? Right, so 5 pi over 4. Well, this is 4/4. One more is 5/4. Right, so if we wanted to know, the reference angle is still pi over 4. The reference arc, whatever you want to refer to it as. So this is going to be, now they're both going to be negative. So you're going to have negative 1 over root 2. Negative 1 over root 2. Oh, positive 1. This will be negative root 2. Negative root 2. Oh, positive 1 again. And then 7 pi over 4. I need one more color. This is going well. Red. 7 pi over 4, well, 8 pi over 4 would be a full circle. That's going to be like right here, right? Same reference angle. Still has a reference angle or reference arc of 1 pi over 4. So here, though, you're dealing with positive negative. That's a parenthesis. Very aggressive parenthesis. So your sine is negative 1 over root 2, or negative root 2 over 2 if that's how you're writing it. Your cosine is positive, so 1 over root 2, and your tangent is negative 1. Your cosecant then is negative root 2, your secant is root 2, and your cotangent is negative 1. So just think about how we're really in this working with 1 over root 2 is the thing that's really important about knowing 45-degree angles or like quarters of the circle or semicircle to help you kind of keep it in order. So what about this 30-degree angle? It's got a radius of 1, right? We know how much are we going up, how much are we going over. So this has a radius of 1. Let's think about a 30, 60, 90. If this is 1, how do you go from the hypotenuse, we did this on the warm-up, to the shortest side? Well, it's 1/2. And then how do you go over here? Oh, it's root 3 over 2. Right, so this is going to be root 3 over 2. This is going to be 1/2. So what is this coordinate point going to be? Root 3 over 2, 1/2. So the sine, right, think it's just y, and this is just x. The sine of 30 is going to be 1/2. The cosine of 30 is going to be root 3 over 2. What would the tangent of 30 be? We're going to do sine 1/2 over cosine root 3 over 2. Ooh, it's hard to divide by a fraction, right? Let's multiply by the reciprocal. Oh, these 2's are going to cancel, so you get 1 over root 3, or maybe you're saying root 3 over 3 for rationalize that. All right, so now you've got the sine, cosine, and tangent, and then you can think about, well, what do you need to do to get the secant, cosecant, and cotangent? If we put this in the next quadrant, in quadrant 2, what's going to happen to it, right? That's going to be 150 degrees. But if we slide it on over, it has a reference angle of 30, right? So this is asking you, this is 150 degrees. That still is a reference angle of 30. That coordinate point is going to be negative root 3 over 2, 1/2. What is that angle when we put it in the third quadrant? We're going to write these down a little bit more formally in a moment. If we go into the next quadrant, oh man, I wanted to write it in the next quadrant. This is going to be 150 degrees. If we go down here, it's going to be 30 more than 180. This is going to be 210 degrees. Oh, it's going to be negative root 3 over 2, negative 1/2. What about if you go to this very last quadrant? Right, it's 30 degrees less. That's what, 330? That's going to be root 3 over 2, negative 1/2. Right, positive, positive, negative, positive, negative, negative, positive, negative. What about if we look at a 60-degree angle, our last special angle? So here, best triangle I've ever drawn, the radius is 1, but this is the 30 degree. This is the shortest side. So this is the side that's going to be 1/2, and this side will be root 3 over 2. Right, so what is this coordinate point going to be? Well, you're going over 1/2 and up root 3 over 2. So 1/2 root 3 over 2. So the sine of 60 is going to be root 3 over 2, and the cosine of 60 is going to be 1/2. Well, what is the tangent of 60 going to be? Root 3 over 2 divided by 1/2. Oh, we don't like dividing by a fraction again, so times 2 over 1. These will cancel. Oh, look, root 3. Right? What is this angle when you reflect it and you put it in quadrant 2? Right, so it's 60 degrees less. It's a bit, now this is, that's 1/3. This is 2/3 of a semicircle. So that's going to be what, 120? Right, so that coordinate point is going to be negative 1/2 negative root 3 over 2. If we put this in the next quadrant, and now it's 60 degrees, right? So the reference angle is still 60, but it's going to be 60 degrees past 180. That's going to be what? 240? Right, so if we went all the way around here, 240, oh, that's going to be negative. If we go into the last quadrant and reflect it, ooh, that's terrible, isn't it? Oh boy. You guys are gonna have no idea what I'm doing. And I go to that last one. That's going to be, well, 60, that's going to be 300, isn't it? So that's going to be 60 degrees before I get to 360, right? And that's going to be positive 1/2 negative root 3 over 2. So hopefully you're noticing a lot of patterns. So this is where you guys have a sheet that you could follow along with me on, I believe. So 45 degrees are pi over 4. Okay, so the sine of 45 degrees, I'm going to draw these in, is what I'm going to do. So this is 45 degrees or pi over 4 radians, right? This coordinate point right here is going to be 1 over root 2, 1 over root 2. So that means that the sine of 45 is going to be 1 over root 2. In this quadrant right here, this is going to be 135 degrees or 3 pi over 4, right? And that coordinate point is going to be negative 1 over root 2, 1 over root 2. So that means that the cosine of negative 135 is 1 over negative root 2, right? In quadrant 3, this right here, well, that's going to be 45 degrees past 180. So think 180 plus 45, or this is 5/4, right? I think I can get that a lot easier. 5 pi over 4, or what is this? 225 degrees. It's going to be negative 1 over root 2, negative 1 over root 2. That's not negative 45 degrees, right? This right here is going to be negative 45 degrees. So this will be 360 minus 45, which is 7 pi over 4. Or it's, oh goodness, 315? Yeah. Right? This is also going to be negative 45 degrees because that means that you're going, that negative means that you're going clockwise. So this will be negative 45, and this coordinate point is going to be 1 over root 2, negative 1 over root 2. So if I want to find the tangent, that's going to be y over x. Well, if I do y over x, I'm going to get negative 1. So think in terms of the unit circle. Let's look at the 30 degrees. I'm going to split this up, and I'm going to draw in all my 30s. And then we'll put it all together. So there's a 30. Oh, so all my angles that have a reference angle of 30 is what I'm drawing in. Okay, so this is 30 degrees or pi over 6. This is 150 degrees or not quite at 5 pi over 6, right? These are all sixes. 30 degrees is a sixth. This is going to be 210 degrees or 7 pi over 6, right? It's 1/6 past half a circle. So 1/6 past pi is going to be 7 pi over 6. This is going to be 1/6 away from a full circle, so it's 330 degrees or 11 pi over 6. Right? So this coordinate right here is going to be root 3 over 2, 1/2. Right? Think about that. This is the 30-degree angle right here. So across from the shortest side, which is going to be the radius divided by 2. So that's where you get the 1/2. And then the 1/2 times √3/2. So then that means that this is, now I can just think about the quadrants. Negative √3/2, 1/2. Negative, negative, negative √3/2, negative 1/2. And then positive, negative, √3/2, negative 1/2. Right, and if I wanted to know, let's think about these. The sine of 30, well, I have that is 1/2. The cosine of 210, well, I have that, negative √3/2, because this is x, this is asking me about y, and then the tangent of negative 210. So this is actually going to be, because the negative is telling you to go clockwise. Well, I go clockwise, oh, that's 180, oh, that's 210. Right, so this is going to be negative 210. So this is going to be the same thing. Its coterminal angle, if you want to think about that, is 150. Right, or just think about which quadrant is that in, and then you know the 30. So this would be in quadrant 2. So the tangent is going to be sine over cosine. So if it's 1/2 divided by, you know what, or times negative 2 over √3. So it's negative 1 over √3. Or maybe you're going to say negative √3/3. Both are perfectly acceptable. Awesome. Didn't I do this? Didn't I do the 60? I did 30. I did 45. Did I not do 60? Am I losing it? I didn't do 60. Interesting. I felt like I did. Okay, let's look at these 60s. Right, so this is going to be 60 or pi over 3. Its reflection right here, so 60 degrees before you get to 180 is 120. Or, that's 1/3, there's going to be 2/3, 2 pi over 3. 60 degrees past 180 is going to be 240. Or, oh, that's a third of the way, a third past half a circle, so that's going to be 4 pi over 3. This is kind of like 3 pi over 3. It is 3 pi over 3. And then this right here is going to be 1/3 of the way until you get there, right? So this would be 6 pi over 3, so this will be 5 pi over 3. Or 300 degrees, right? And then the coordinate points that go with that are, I mean, it's just gonna be flipped, right? It's almost like the inverse of the 30 degrees is really what's happening, because technically, as if we were to graph it, it's a reflection of the line y equals x. So this will be 1/2 √3/2. Once we know that one, we've got negative 1/2 √3/2. This one's going to be negative 1/2 negative √3/2. And this one would be 1/2 negative √3/2. So if I asked you for the sine of 60, well, that's right here. That's going to be √3/2. The cosine of 240, that's down here, right? The cosine of that is going to be negative 1/2. You can just think about it and be like, oh, that's a 60-degree reference angle. If it's a 60-degree reference angle and it's in the third quadrant, then I know cosine of 30 is 1/2. I'm sorry, cosine of 60 is 1/2. And then I know it's in the third quadrant, so I know cosine has to be negative. And then the tangent of 120, right here. So you're going to have √3 of y over x. Instead of dividing by a fraction, let's multiply by the reciprocal. You're going to get negative √3. So the other piece before we kind of just sum it up is we have coordinate points in all 4 quadrants that represent 30, 45, and 60. But we also have the boundary coordinates, which I spoke about in the last lesson a little bit. These points right here. So they have the points, you have a radius of 1, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And so if we look at the sine, cosine, and tangent of each one of these, the sine of 0, well, this is 0. This is 90. This is 180. This is, 270. and then back to 360, right? Or maybe you have 0, pi over 2, because you're splitting it in halves, half of a semicircle, pi, 3 pi over 2, and 2 pi, right? So the sine of 0 is going to be 0. The cosine of 0 is going to be 1. The tangent is going to be sine over cosine, y over x, 0. The cosecant, well, what's the reciprocal? If you have 0 and you do like a number divided by 0, that's undefined. The secant of 0, well, what's the reciprocal of 1? 1. What's the reciprocal of 0? Undefined. The empty set. What about a pi over 2, right? That's 90 degrees. It's the same thing. That's this up here. The sine is going to be 1. The cosine is going to be 0. The tangent is going to be sine over cosine. Well, what's 1 divided by 0? Undefined, or the empty set. Well, the cosecant, the reciprocal of 1 is 1. The reciprocal of 0 is undefined. Cotangent, right? So now you're doing cosine over sine. Oh, that's 0. What about a pi? That's the same thing as 180 degrees. So the secant of pi, the sine of pi is 0. So you're over here. This is pi. Focus on this. That's your y value. This is your x value. This is y over x. This is x over y. This is 1 over x. This is 1 over y. The cosine of pi is going to be -1. The tangent is going to be 0, y over x. If you do 1 over y, you're going to get undefined, right? 1 divided by 0. What about 1 over -1? Oh, that's just -1. What about x over y? -1 over 0? Oh, that's undefined. What about 270, which is down here? Or 3 pi over 2, it's the same equivalent. The sine of 270, -1. The cosine of 270, 0. The tangent of 270, undefined, right? You've got y, you've got x, and you've got y over x. You have 1 over y, this is going to be -1. You have 1 over x, this is going to be undefined. And then x over y. X over y, 0. So the idea is that you're allowed to use a calculator to evaluate the trig functions or for non-special angles. And so it's not going to be our main focus, but if you have something like the tangent of 17 or pi over 7, those are not special, you would have a calculator with you if you were asked to generate something for that. However, if we're working with special angles and angles that are on the unit circle, so like the 30, 60, 90, 45, you're not going to have a calculator with you. You want to know those, and you want to know those well, right? Like you really want to work with them and practice your speed with that and your fluency with that. So like 405 or 5 pi over 3, you want to think about what is the reference angle for that, and then which quadrant does it fall in. So if we just now that we have all of this, let's just fill in this unit circle with the coordinate points. So here we've got 1, 0. Here we've got √3 over 2, 1/2, right? We really just need the first quadrant, and then everything else comes a little bit more naturally. Here we've got 1 over √2, 1 over √2. Here we've got 1/2 √3 over 2. And here we've got 0, 1. And now everything else is just a reflection, right? Like I can do all the 6s, all of them, right? Like I can do, this is now -1/2, because I'm just thinking about what is true in each quadrant, right? Like this was positive, positive. This is negative, whoa, darn. Negative, positive, negative, negative, and then positive, negative. So then I can just fill everything in. So -1/2 √3 over 2, -1 over √2, 1 over √2, -√3 over 2. Sorry, that doesn't look right. 1/2, and then this is -1, 0. right? And I can keep going. So now 210, or I'm still on these 6s. And you'll see, take a look at everything that's a 6. You have the same numbers. It's just a matter of thinking about what the signs are. Negative root 3 over 2, negative 1/2. Negative 1 over root 2. Negative 1 over root 2. Negative 1/2. Negative root 3 over 2. And then 0, negative 1. And then the final quadrant, you've got 1/2. Negative root 3 over 2. 315, or 7 pi over 4 is going to be 1 over root 2. Negative 1 over root 2. 11 pi over 6 is going to be root 3 over 2. Negative 1/2. All right, so practice filling that in with fluency. Think about the quadrant and the reference angle. Right, and now we would have, so that tells us the sine and cosine for every single one of these, because sine is y and cosine is x. So I want to go through these, and I have 3 pages of this, and I want to do this, and I want to talk about, I'm actually not even going to, I'm not going to sketch them, I just want to look at the quadrant and the reference angle, and that's kind of how I want to approach this. So like 210 is going to be in the 3rd quadrant, right? What is the reference angle? -30°, right? It's 30 degrees past that. So then you can think about, well, that coordinate point, if it's in the 3rd quadrant, both will be negative. If it's 30 degrees, you're going to have negative root 3 over 2, negative 1/2. Right here, 315. Well, that's going to be in quadrant 4. That reference angle is going to be 45 degrees. So that means this coordinate point is going to be 1 over root 2, negative 1 over root 2. Negative 270, this is a boundary angle. This is actually zeroing negative. It's actually the same thing as 90 degrees. It's equivalent. Its coterminal angle is 90 degrees, right? So that's going to be the point 0, 1. It's the positive y axis. About 13 pi over 6. That's more than a full circle. So this right here is going to be in quadrant 1. It's going to be, and the reference angle is going to be pi over 6. It's actually coterminal to pi over 6. So that coordinate point, pi over 6, is going to be root 3 over 2, 1/2. What about negative 3 pi, right? That's more than a circle. That's actually coterminal to just pi, isn't it? So that's the same thing as pi, so that's a boundary angle. And that coordinate point is going to be negative 1, 0, right? Yeah. 3 pi over 4. Well, that reference angle, so that's going to be in quadrant 2, and the reference angle is going to be pi over 4. So your coordinate point will be negative 1 over root 2, 1 over root 2. See how, and yes, I've had more practice, but just try to get yourself to the point of thinking like, what's the reference angle? What quadrant is it in? To help you then arrive at these. So then you're really only thinking in terms of angles between 0 and 90, and you're not thinking about exactly where it is and do I have to draw out the entire unit circle every single time. So let's do the next page and maybe pause the video and try it and try to think through it. So 30 degrees. I'm not going to listen to these directions. I'm just going to keep going with what I was saying. 30 degrees is in quadrant 1 and it's its own reference angle. So that's going to be 1/2 root 3 over 2. 165. I don't like, this isn't a special angle. We're just going to talk about I'm going to skip those. Right? I mean, I guess this would be quadrant 2. And its reference angle would be 15 degrees, isn't it? And this would be in quadrant 4. And its reference angle would be 40 degrees, which are non-special. So we're going to skip them because we would have our calculator for those. Pi over 2 is boundary. Right? That's the positive y-axis, so that's the point 0, 1. We did this one already, right? So this was quadrant 2, and its reference angle is pi over 4. So you're going to have negative 1 over root 2, 1 over root 2. And negative pi over 3 has a reference angle of pi over 3, and that's in quadrant 4. So you're going to have, sorry, that's a pi over 3. You're going to have, it's going to be positive 1/2, negative root 3 over 2. Right? Oh, it's just like this one. It's just the reflection of it. And a few more. So 225, well, that's in quadrant, what is that, 3? And that is going to be, have your reference angle is going to be 45 degrees. So that's going to be negative, negative, so 1 over root 2. Negative 1 over root 2. They're both negative. 270 is boundary. Right, so that's going to be the negative y-axis. So that will give you 0, negative 1. Negative 105, I don't think that's a special angle, is it? No. Negative 105, I mean, that would be, if we really wanted to do that, that's going to be, no, quadrant 3, right? I mean, the reference angle is going to be 75, I guess. But this is not special. So we would have our calculator for something like that. 5 pi over 4 is going to be in quadrant 3. Its reference angle would be pi over 4. So it's going to be the same as this, right? These are the same angle. Negative 1 over root 2, negative 1 over root 2. 11 pi over 6, it's a little bit less than a full circle. That's going to be in quadrant 4, and its reference angle would be pi over 6. So that's going to be root 3 over 2, negative 1/2. And then negative 5 pi over 2. Its reference angle is going to be, I mean, pi over 2, but that's going to be a boundary angle. So, it'd be negative pi, negative 2 pi, negative 5. So that would be like your negative y-axis. 0, negative 1. Is that right? Right, so this, I'm starting here and I'm going clockwise. That's 1/2, 2 halves, 3 halves, 4 halves, 5 halves, yeah. Awesome, so just keep practicing. So just a fun way to remember this, the positivity. So A, everything is positive in quadrant 1, all trig functions. S, only sine is positive in quadrant 2. Only tangent is positive in quadrant 3. And cosine is positive in quadrant 4. So if you remember this, all students take calculus. All students take calculus. So everything, just sine, just tangent, just cosine. So this is telling you what is positive in each quadrant. All right, and then you know the 6 trig functions, like what is their sign in each one. Okay, so we're going to do some application of this to finish up this lesson. So cosine of pi over 4, right? So you want to think about what is the x value at pi over 4. Don't pick up your calculator for this, right? So this is going to be 1 over root 2 times 5 pi over 3. So let's think about quadrant. Well, 5 pi over 3 is going to be quadrant, and you can think through this slowly right now, quadrant 4, right? And the reference angle is pi over 3. So what is your coordinate point there? 1/2 negative root 3 over 2. Right, so if you do y over x, negative root 3 over 2, instead of dividing by 1/2, let's multiply by 2. So this is going to be negative root 3. Right? So that's going to give you negative root 3 over root 2. And you know what? Leave it like that if you would like. Or we could go a step further and rationalize. So times root 2 over root 2. Negative root 6 over 2. About cosine of pi over 4, we did that one, right? 1 over root 2. Tangent of pi over 2, that's a boundary angle, right? That's the positive y-axis for this. So that coordinate point is going to be 0, 1. So if you do y over x, 1 over 0, oh, that's undefined. So there is no solution to this. So I would maybe pause the video and give these a shot. Cosine of 180 degrees, -1. The cosine of 45 degrees, 1 over root 2, minus the sine of 180 is 0. So it doesn't even matter if you know what the sine of 45 is. It's 1 over root 2, but anything times 0 is just that. So you end up with -1 over root 2. So here I would think about cosine, right? I would say, well, what is the cosine of pi over 3? And the cosine of pi over 3 is, right, we're going to need that anyways. And you know what? Here's what I would probably do for this. The secant of pi, so this is 1 over the cosine of pi over 3 times the cosine of pi over 3. I should have kept reading. That just cancels out, and this whole thing is just 1. Plus tangent of pi over 3 times 1 over the tangent of pi over 3. Doesn't that just cancel? Plus 1, so you just get 2 for this. Neat. The sine of pi over 3, had you done it the way I first started to think, you would have gotten this also. It just would have been a different way of getting it. Sine of pi over 3 is going to be, what is that? Root 3 over 2 plus 6 times 1 over root 2. Let's see. Root 3 over 2 plus 6 over root 2. Oh, God. Should I try to come up with a common denominator? I guess I should. I'll multiply this by root 2 over root 2. And I'll multiply this by 2 over 2. So I get root 6 over 2 root 2 plus, oh, I had a better way I could have done this. Whatever. It's fine. 12 over 2 root 2. So I've got 12 root 6 over 2 root 2. So that's 6 root 6 over root 2. Isn't that just 6 root 3? Because I can combine these two. I could have rationalized this back here, and then it would have given me a denominator of 2 for both of them, and I would have had root 3 plus 6 root 2 over 2. Root 3 plus 6 root 2 over 2. Is that the same thing as 6 root 3? No, did I make a mistake somewhere, guys? Root 3 divided by 2 plus 6 divided by root 2. I definitely made a mistake, but I'm like, now I'm not sure where. So this is root 6. Oh, because I'm adding. You guys didn't tell me that. Let's back up with that. I'm going to clear my writing. Sorry, I'm going to erase the page. Okay, I'm going to go back for a second. This is root 3 over 2 plus 6 times 1 over root 2. Root 3 over 2 plus 6 over root 2. I'm going to rationalize this side, so root 2 over root 2. So I've got root 3 over 2 plus 6 root 2 over 2. Right, that's just root 2. So root 3 plus 6 root 2 over 2. There we go. And this last one, sine of 300, right? So think the reference angle is 60 degrees. And this is going to be in quadrant 4. The sine of 300 is what? So the sine of 60 is root 3 over 2. So it's going to be negative root 3 over 2. Times the cosine of 60 is 1/2. And it's going to be positive 1/2. So you're going to have negative root 3 over 4. right? And you can always, as long as you're in degree mode, you can always just, hey, pop into your calculator and see if that's the decimal that you get. Negative root 3 divided by 4, it was. So some application of the unit circle. So this last one, so sine squared of 7 pi over 6 plus cosine squared of 7 pi over 6. Right, so this is the same thing as saying the sine of 7 pi over 6 squared plus the cosine of 7 pi over 6 squared. It doesn't matter as long as those are the same, it's always going to equal to 1. So watch this. This is what I started off with. These are any points on the circle. So, right, because this is like saying y squared plus x squared is all that it's saying. So 7 pi over 6, the reference angle, so 7 pi over 6 is in quadrant 3, right? And the reference angle is pi over 6. That's important. So that coordinate point is going to be negative root 3 over 2, negative 1/2. So the sine would be negative 1/2 squared plus negative root 3 over 2 squared. Well, when you square, you distribute. So you're going to get 1/4 plus, well, when you distribute, 3/4. Oh, that's 4/4, which is 1. As long as the angle that we're talking about is the same, all that's saying is, oh, here's a point on your circle, and we knew that the radius was 1 because we're working with the unit circle. So, oh, I forgot to put the objective at the end, so I'll fix that. Let's go all the way back to it then. You think we can do that to make sure that we mastered everything we needed to talk about? It was a loaded lesson, guys. Now you're looking at everything in reverse so quickly. I bet a lot of you are just going to pause the video and not wait for me to check if we did everything we needed to do. You're going to be like, I'm good. Oh, there, I passed it. So given the angular arc measures of any angle, we'll be able to determine its corresponding point on the unit circle and resultantly determine the exact trig value of those special angles. So of 30, of 60, of 45, and 90. Great job. Keep practicing. Encourage yourself to practice without your notes, right? And prepare yourself because we will be doing some practice under pressure, timed, and I will do my best to simulate that because I do think that it is great practice for every single one of you. Thanks for watching, guys.